Hello and welcome to another SETI Live. I am your host, Beth Johnson, Communications Specialist here at the SETI Institute. Thank you for joining us, everyone. Welcome. Welcome to our viewers from around the world. Please let us know where you are watching from. Today, we are joined by Dr. Georgiana Kramer, a senior scientist and lunar expert from the Planetary Science Institute. We are going to talk about NASA's Artemis mission, which seeks to land the next people on the moon. And the ultimate goal is to build a lunar base, establish a long-term human presence, and perform research. Before they get there, however, NASA has to launch the Artemis I mission, which will be the first in a series of, quote, increasingly complex, unquote, missions, and is currently scheduled for Saturday. So thank you for joining me, George, and welcome.
Thank you. It's really great to be here.
And welcome to our viewers. Well, we've already got people. Wow! Thank you to I'm gonna show this one. Thank you for the super sticker, much appreciated from me. And thank you to the people who've already said that they're here from Colorado Springs and from Guatemala. Buenos dias. And wow, so let's get started. As you see, George and I both have some fabulous lunar backgrounds going.
Yeah, we're on different parts of the moon, though.
We're on different parts of the moon, right? Exactly. So, but so tell us about Artemis I. What is Artemis I? What's the point of that one?
Oh, Artemis I. Excuse me. Artemis I is testing, the launch and the capabilities to go out to the moon and come back in a very general sense. But it is going to be carrying with it some science experiments and also some other satellites, some CubeSats. So yeah.
And do you know what any of these CubeSats are going to do, or what some of their scientific purposes are?
Yes, I did write down a list. So you'll see me like looking over and reading from it. So it's going to deploy 10 CubeSat satellites. And I think I have four of them here listed. There's 2 of them that are going to go look for ice at the polar regions, especially in detail. And one of them is called the Luna H map, and it's going to be using a neutron spectrometer to again look for make the highest resolution maps in the South Polar region for where hydrogen might be. And the reason that neutrons work to do that is because great time to have a frog in the throat, is because hydrogen absorbs neutrons. So at least some of the neutrons. So they actually, if they're finding places where there's not as many neutrons in other places, good chance that's because of the presence of hydrogen. And if you got hydrogen, you probably got water.
And water, of course, is key for having an eventual lunar base there, correct?
Yes. Yeah. Water is like it's the gold that we are going for. Yeah.
And it's not just for the astronauts. What else are we planning to use water for while we're on the moon?
Water's got a bunch of great resources. Just a sec as I put my dog down. You can use water as a shield from radiation and solar wind. You can use water I guess probably it's a lubricant. And probably most importantly, you can use it to make rocket fuel.
Right. And that's, of course, will save us rocket fuel going back and forth, because then we don't need to take rocket fuel to get back. So how is this Artemis I test mission? What are we're looking at the SLS, which is the Space Launch System rocket, and the Orion spacecraft finally in combination, and we're actually going to send them off to the moon together. Do you have a timeline for what's going to happen with this particular launch?
Yeah. So with this one, it's supposed to take about a month, I believe. It's going around the moon, and it's once the Orion capsule leaves the Earth's magnetosheath, then it will be able to run some particular science experiments that people are interested in, which really has to do with radiation happening to yeast, bacteria, and also to women. Apparently, and I didn't know this until looking into this, apparently women's bodies are more vulnerable to deep space radiation than men's are. So they are actually launching 2 dummies that are supposed to be female dummies and they have radiation monitors in their organs. Oh, was my hand like disembodied? That's pretty neat. So, so that's going to go around the far side of the moon. I think probably orbit because it's supposed to be out there for a while, and then it comes back, and they will be able to actually look at these results of the science experiments.
So, the Space Launch System, I know there's been a lot of controversy about this, but what makes this rocket so different? Is this a very different rocket from previous rockets? What's important about this? Why are we trying to get this one to work?
I don't really know much about this other than we need something bigger. It's my understanding, and I'm sure that there are aeronautical engineers that are going to just come out of the woodwork and freak out on me for saying this, but it's my understanding that we really haven't technologically got beyond the whole, we can barely get off of this planet with the technology for propulsion that we have. It's just we need to have all of this fuel, but we need to lower the mass, but we need to have all this fuel, which has mass, just to launch off, so we can barely carry anything into space. So it's my understanding that SLS was an advancement, at least in the technology, not of the fuels per se, but rather the way that things are being put together. I'm sorry, I'm a scientist, I'm not an engineer. I really do apologize. But it is the largest rocket that we have made as NASA has made, and that has been made, I think. And there's a graphic up here that I found that is showing what the SLS looks like compared to the Saturn V, which was previously the largest rocket, which was used to get to the moon. But the SLS can have other configurations or other attachments to carry crew, or just to carry transport material to the moon or elsewhere, or just transporting stuff to Lunar Gateway, which is like this space station that we're going to be building at near lunar orbit. So SLS is supposed to be capable of bringing these things into orbit, these big things, so that we can finally go and be habitating the moon for a while and go on to Mars.
Okay, so that's sort of Artemis I. What do we know what the timeline is for Artemis II yet? Is that sort of laid out, and what that covers?
A bit.
A bit.
So Artemis II doesn't have a whole lot of, I couldn't find at least any very specific deadlines, and that has largely to do with the fact that it really depends on the success of Artemis I. So provided everything's cool, they're going for 2024. Hopefully they're going to stay away from the early April timeframe when we have a solar eclipse going through the country. But right, it's supposed to be launching in 2024. And in general, it's going to be carrying the first people back to the moon, potentially carrying these people to the furthest away in space, away from Earth, that humans have ever been. And they are expected to stay out there for anywhere between 8 to 10 days, possibly even a couple of weeks. Again, depending on how things are going, and then return back.
Okay, but it's still not touching down on the moon, right? This is still just another orbital test.
Right, yes. Okay. Yeah, they just have to make sure. They have to do the kind of like dress rehearsal.
Right. Okay. So the ultimate goal is Artemis III. What is Artemis III setting out to do?
Artemis III is set out to land people on the moon again. And it is going to the South Polar region because that is the best. That is where the best evidence for existing water ice and at an accessible location as well is.
Okay. So, I'm going to say hello to some more people here. Let's see, we've got people now watching from the UK, from Louisiana, from Florida, North Carolina, South Wales. Hello. The White Mountains National Forest. That sounds lovely in New Hampshire, I think. More people from the UK, from Toronto. Thank you so much. Welcome everybody. My guest today is George Kramer. She is a lunar science expert, and we are talking about NASA's Artemis mission and this potential return to the moon. So are you working on any specific projects for Artemis, or are you just excited about the lunar science that's going to be happening?
Well, I'm excited about the lunar science that'll be happening. I'm working on moon things, but I'm not, excuse me, officially involved in any Artemis project.
And so what are you looking forward to? What are you hoping that we understand, learn, discover in all of this process of getting people back to the moon?
That we can stay there. And that the moon is the best. I can't believe I'm choking. This is, gosh, I'm having all these like hiccups. It's like, I'm really not a sick person. Anyway, we're, I'm really hoping that we are going to demonstrate that we can go back to the moon and we can stay there. I'm hoping that we can find accessible water ice that we can extract and use to help us get to Mars and even other locations. Yeah, that's what I'm hoping will happen.
Sorry, I'm having a small technical difficulty over here. Okay, a few more shout outs. Sorry to our Facebook viewers. I guess Facebook decided to choke on the technology today. Welcome everybody now joining us from Facebook Live. Sorry about that. Welcome to our viewers who are coming in from Ghana, New York, Chicago, Australia, Manitoba, some more from the UK, Scotland, San Diego. Wow, lots of people from the UK. Welcome, everybody. Glad you have all survived your heat waves. And Oklahoma. So thank you again, and much appreciated for everybody here. So, George, tell me something about the moon that you love and that you learned.
Just one thing?
Just no. You know what? Give me your top 5. Let's start there.
No, it's too much. It's too much. It's too much. No. Well, I mean, the moon is not boring. We have not been there and done that, I guess. You know, we've been to such a tiny little location. Well, okay, we've been to like 5 tiny little locations, but we really, it was all on one half of the hemisphere. So we are now going to a vastly different location. We're going to be learning some incredibly different things about how cold it can possibly be in space, among other things. So one of my favorites is I was on the Moon Mineralogy Mapper, which was an instrument that uses visible and near infrared wavelengths to map the surface of the moon. We can look at the mineralogy, and which is why it was called that. It was actually flown on the Chandrayaan-1 mission, the Indian mission, their first mission to the moon, which was just amazing. That was a huge success. But what we discovered, so it's called Moon Mineralogy Mapper M-Cubed for short. M-Cubed was built to study not only the minerals, but it went out in its wavelength range just far enough that if there was water in existence, it would be able to catch that signal. And indeed, we did find in some places like water. We found some places where there was more water than others, but that might actually be suggesting a location where it could be harvested potentially. But most importantly, to me anyway, I mean, certainly I'm excited about harvesting water, but there's this other kind of water, which is probably not really harvestable, but it's a phenomenon that happens across the lunar surface. And I like to call it space dew, DEW, because it kind of acts like dew in the morning. So if you can imagine, there's kind of like this surface layer of like a water, maybe even hydroxyl, so H2O or OH on the surface. And then as the sun rises on the moon, it starts to burn off. The energy starts to burn it off and it goes away. So near the equator and up like out to about plus or minus 30 degrees latitude, it goes away during the daytime. And then when the moon is rotating into dusk, it starts to stick again. And it stays throughout the whole lunar night. Now it's a really thin layer. It's, several molecules thick, but again, and it's all on the surface only and across a vast regions, the entire lunar surface. So it might not be really useful for extracting water, but it certainly is a very neat phenomenon.
That I've heard about that recently, and that is very fascinating. And I'm excited to learn more about that as well. Welcome to viewers now coming in from Budapest, Florida, Germany, and Portugal. Wow, we're getting a nice global audience going today. So tomorrow or Saturday, I keep thinking it's tomorrow because it was originally supposed to be
Right,
Friday, but
yeah.
it's Saturday now. What are you going to be doing? Are you going to be watching this? Are you going to be? You're not going to be there, right? Because you're not in Florida. You're in Texas.
Yeah.
So are you going to be just watching that on NASA TV with the rest of us?
Yeah. But I
and
do I
and
do have designs to just go into Florida for Artemis 2 or 3 and just I mean, I never got to see a Saturn V launch. I really would like to see one SLS launch.
that would be amazing. I think I got to see one shuttle launch once from not we hadn't quite made it to the coast, so we weren't out there yet. We were in Orlando. So it was really interesting
Yeah.
just to see that. But I can imagine that up close and personal ish would be incredible. So we've got a good question here. So this is from someone who is calling themselves Moon, so very appropriate. Might the moon do add to its shine? Is it noticeable, and how was it discovered?
Okay. Does it add to its shine? That's a really good question, actually. I don't think so. Nah. Wait. Man, that's a really good question. Would it add, I guess it couldn't add to its shine because that would all depend on the sunlight reflecting off of it. And since the most incident and most intense sunlight reflecting off of it is burning it off, so it couldn't add to its shine, I guess. Um, and how was it discovered? Is that right?
Yeah. Is it noticeable, and how was it discovered?
Is it noticeable? It's not noticeable unless you have this. You can see this absorption feature because of molecules of water ice absorbing particular wavelengths of light. That's the only way to see it. So we can't see with our eyes out there. It was discovered because it was actually discovered by 3 instruments on 3 very different missions. And they all kind of needed each other to confirm it. So it was discovered by the Epoxy mission, which is was renamed from Deep Impact. It used to be Deep Impact. Once their mission ended, they kept doing stuff and they were called Epoxy. I don't remember what it stands for, but they have a near infrared spectrometer on it that measured it as it was coming near the Earth Moon system. Also, Cassini's near infrared spectrometer measured it too. And again, this is where they're looking at like the entire lunar disk, but they are able to see it in various times of illumination. So they were able to actually detect that, yeah, there is this absorption feature that is very diagnostic of the presence of water and hydroxyl on the lunar surface, and it would vary with the day-night cycle on the moon. The M cubed instrument is much closer. It's orbiting the moon, so it doesn't get the whole moon at once. It's measuring swaths, like like what Google does when it takes pictures of the Earth. And it was discovered because we were looking for it. We weren't looking for space dew, but we were looking for water on the surface of the moon. So it was one of the things that we looked at and saw, and wow.
So it seems to me that that's sort of one of the biggest questions we've solved, but we keep solving it a bit more, is this water on the moon question. Before it was sort of, no, there's no water on the moon. Then it was like, well, you know what? Actually, there could be some water on the moon. Oh, well, there's some permanently shadowed areas that probably have some ice. And now it just feels like there's water. It's just getting it that's kind of the trouble now.
Right. Yeah. There is really overwhelming evidence that there's water. And one thing to note, oh wait, I was thinking of a different instrument. I could be wrong about this. Maybe there's a neutron spectroscopist out there that can help. I believe that the neutron spectrometer, it doesn't see very deep. It might be a meter or something. So if it's detecting that or if water's absorbing it, then it's going to be near the surface at least. But one of the questions is, how dirty is that water? Because I mean,
Right.
let's face it, we're not going to have literal swimming pools of ice or ice rinks or whatever. It's going to be very dirty, mixed with the regolith and such, potentially completely buried even. We might have to drill down to get access to it at all. So there are those questions. I also think that all of these measurements have been taken from orbit. So if you can imagine, like, you're flying over a cave and you can't even tell really that there's maybe not can't even tell there's a cave mouth, but maybe you can, and there's like you can go in there if you were on the ground, but not from orbit. There's going to be a lot of places like that on the moon, especially near the polar regions, and they're going to be better than permanently shadowed craters because they're going to really, really never have seen sunlight, and water can get trapped in there just as easily as it would in craters in the polar regions. I think those are going to be the better places to look.
And that's definitely, I know that's been one of the scientific objectives of quite a few people that I've spoken to, where they're talking about lava tubes and being able to get into there. And I know one of our scientists here at SETI is working on designing a drone that could possibly go down into lava tubes and take a look for things like that. So that would be definitely awesome. Oh, we have another question. Here we go. Could we get those small amounts of water to condensate on a lander to extract some water without digging?
Okay, so again, I am very far from an engineer, although I am engineer curious, I guess. I would love to speak with a material engineer or something that might be able to come up with a way that we could actually try harvesting this, because this phenomenon, it's coming from the solar wind. The sun is throwing hydrogen protons everywhere, and a lot of them are hitting the moon's surface. And it so happens that terrestrial planets usually have a lot of free oxygen. I mean, not free like it's floating around, some of it, but just a lot of oxygen. And on the surface of the moon and even on Earth, there's a lot of oxygen available. Even if it's in a mineral and still in a rock, that oxygen is kind of exposed because there's a lot of oxygen in the minerals. So if that oxygen is exposed, little negative charges can attract those positive charges, and you have like an H2O bond. It's a weak bond. It wouldn't stick around very long. But if you could extract that oxygen, which is a thing, and dope it into a material or something, and we don't even have to be on the moon. We could be in orbit with that material with a giant solar sail or something that's collecting hydrogen, funneling it down. I don't know. Could we?
Well, that's definitely a question for the engineers, it sounds like. I have another question that came in from Facebook. Unfortunately, again, technical difficulties, cannot share the question on screen. But we have MOXIE working on Mars, converting oxygen, carbon dioxide into oxygen. Do we think there's a way that we could do something similar for water conversion on the moon, using something sort of like MOXIE there as well?
I would just use the rocks.
Just use the rocks.
Yeah. I think that I think we're going to need the rocks to get oxygen. And then we can, mix the oxygen with hydrogen. I mean, I'm going to be surprised if there's ever enough water on the moon to really have a robust reservoir for interplanetary travel.
Right. Okay.
I'm not saying there isn't. Okay. I'm a little skeptical. Not that there might be there, it just might be really like too difficult to get to. But there is a lot of oxygen in the rock. So if we need oxygen for breathing purposes, I think that's probably the best place to get it.
Okay. So we're at the end of sort of our half an hour here, and I have one question. Well, two kind of that I'm curious to ask you. One, if you were given the opportunity to go be a part of this lunar base, would you take it? Yes, absolutely. Two, and this is a question specifically for you here. Would you want to be able to bring Gozer?
Of course. I think actually I'm pretty sure that I would be allowed to bring Gozer. Okay. I think they would want me to bring Gozer.
Gozer is your honorary partner in crime.
Yes, she is.
She is a fabulous dog. I am thrilled that I finally got to meet her in person. Well, so George, thank you so much for joining us today, and thank you to, of course, all of our viewers for joining us today and hanging out with us and asking your great questions. Obviously, we need to bring some engineers on here and figure out what we can do. After Saturday or maybe after Monday, I make no promises here. I'm looking forward to talking to you and seeing how this all went. So if you guys are, excited about the return to the moon and Artemis mission, make sure you check out NASA's schedule for Saturday for the Artemis I launch. And, take a look at it, get involved, get excited. We're going back to the moon, and I know there's a lot of us who are thrilled to finally see this happen. So,
I think it's
all
at
right, well,
2:17 p.m. Eastern. I think
that
it's
sounds right. That sounds right. I remember it was a time that it wouldn't be 5 in the morning for me, so I was actually a bit more thrilled about this one than
enough West Coast
Mondays.
people complained.
Yeah, you know. All right. Well, thank you everybody for joining us. Thank you, George, for being here with us
This
today.
was
And
fun.
we will see you guys next week. We will have a stream on a new SETI Artist in Residence project called Xtopia. So we will be back here with our Artist in Residence director, Bettina Forget, and one of her artists. So come back then for that, and we'll see you then. Have a great rest of the week and long weekend for those of you here in the United States.
Bye.
Bye.
Thanks.